Hello, everybody. Hope you're doing well. My name is Mahmoud Kiasari, and welcome to the new chapter of Advanced Algebra. So in this chapter, we are going to talk about, as you can see, solving a system itself. So by definition of that, we mean we do have a couple of equations, sometimes two, sometimes three, and we would like to find specific points. At first, we have to talk about the definition. What does it exactly mean when we are trying to say that we're solving a system? Then we are going to talk a little bit about basic things that we already know, as I just talk about it, about the two lines that we could find specific point that they do have intersection. Then we will talk about more advanced topic over here. So without further ado, let's just talk about it. So at this point, we do have the definition of solving a system, and we would like to see what does actually mean. First of all, we have to have a definition of our system. The system is a set of multiple rules, equations, or it would be inequalities. By the way, we are going to cover both of them, that must all be true at the same time. It means that when you have two systems, for instance, where we are talking about two lines, the system at this point means that there is the exact part that they do have intersection with each other, which somehow leads us to a solution. Solution is going to be a point or a set of points, because sometimes when we are dealing with lines, we only have one, none, or maybe infinite, and when we are talking about curves and other kind of things, it would be a little different. But at some point, we are going to have a solution, one solution, our set of points that are going to be solutions that satisfy every rule in the system. So the whole system is two lines. This specific part is the solution itself. And the key idea over here is that visually, the solution, again, is where the graphs of all the roots, this guy is a rule, intersect, and it means that that's going to be their common ground. This specific point that we consider as a solution is going to be there, that both of my rules, the rule number one and the rule number two, are going to agree and have common ground. So at one point, we are going to have one solution. If you guys remember, when you have two lines and when you have one solution, means that those lines are going to be completely different with each other. It means that they shouldn't have the same, some kind of slope or the coefficient beside our x, so y is equals mx plus b. And when we do have no solution, means that those lines are completely identical, and the only thing that would different is going to be y interaction or y interception. And finally, when we do have infinite, means that those lines are completely identical. Y is equals to x plus 1, another y is equals to x plus 1. Those are completely identical, and they're going to have infinite number of solutions. So that one was for some kind of basic section. But in this point, in this subject, we are going to be in detail, and not only we are going to consider two lines. Sometimes we're going to have one line, one curve, maybe we do have two curves, and at some point we are going to touch the 3D thing, because everything that you see over here is just about 2D, x and y. So the high-speed refresher, again, the one that we used to have, is about the 2D toolkit, as we were just talking. We do have different kind of methods in order to find that specific solution that both of the lines are going to agree on that. The very first one is about graphing. As we all know, it means that best for the building intuition. We cannot only trust on graphing that gives me the exact thing or the exact and precise thing that I want. It is going to give me some intuition that what is exactly happening inside my system itself based on different rules that I have. And it's not going to be finding, again, precise answer. After that, we do have the substitution. What does that mean? It means that when you have one of the variables and is already some kind of isolated, we are going to use that specific thing and to solve another question, and then we are going to use the number that we get, put this inside one of those equations, and we can find the second number. It means that when I do have my x, I can put it inside one of those equations, and I can find y. X and y is going to be a set, is going to be a pair that give me a specific point itself. And at some point, we do have elimination. This is going to be the fastest method when equations are in the standard form. If you guys remember, we were talking about it, the method of that having two equations, two unknowns. One of the methods was about the elimination, means that I do have a way of two equations, and I would like to find a way to see that if I can eliminate any of those variables or not. By having that, it's going to be helpful for me in order to find one of the variables, then use that specific value in one of those equations and find another one. So After that, another thing that we have to know is obviously we are not only going to work on the 2D. I'm going to just mention the 3D part. I'm not going to some kind of focusing on that much, but I will show you an example of how we can use that, because sometimes you are not only going to have lines, you're going to have planes. It means that we are living in a 3-dimension some kind of world. We do have x, we do have y, and we do have z, or sometimes we know it as a height. It means that on that times I still need to find a solution. Is there any specific point, rather than just being 2 pairs, this time is going to be 3 pairs, because it's going to be x-axis, y-axis, and z-axis that goes to the top. Is there any specific point is going to satisfy all of those rules? Rather than only one rule, I'm going to have 3 rules. So at that point, it means that equation like this one, ax plus by plus cz is equals to d. If you guys remember, most of the time we were working with this, but at this point, if when I do have z-axis or height, I'm going to have something like this. It means that an equation like this doesn't describe a line, it's going to describe a plane, and a plane is something like that. And the core idea over here is that we do have a 3x3 linear system, and it search for the intersection point of 3 distinct planes. It means that I do have 3 planes, and maybe the only intersection or the only common ground they have is only 1 point, we call it as unique point. Then we do have line of intersection. It means that at some point I'm going to have this guy that's going to be satisfied all of them, and at some points I'm not going to have intersection. It means that there is no specific point or line or area that all of those 3 are going to have a common ground. Guys, listen, when we are talking about different rules, 3 or maybe at some point 4 or maybe more than that, we are talking about the solution. We are talking about a place or specific point that all of them are going to be satisfied. If I do have a point that in my some kind of 3 system or 3 plane system, if I do have a plane that if I do have a section that 2 planes are going to have interaction, but 1 doesn't, it means that still it doesn't work. The solution should work for all of the rules itself, so remember that and be careful. So let's talk about the 3 variable system. Actually, we were talking about 2 variable system in our previous some kind of video, so let's just make it a little bit more advanced. So what would happen if rather than just having x, y, I'm going to have x, y, z? Whenever we do have a question and we would like to answer that, you have to look at your variables. If you only have 1 variable, 1 equation is enough. For instance, we did that 3x plus 1 is equals 5. You have 1 unknown, which is your variable, and you can use only 1 equation in order to solve that. When you have 2 variables, you will need 2 equations to have that. 3x plus y is equals to 5, and x minus y is equals to 6, whatever. If you have 3 unknowns, or if you have 3 variables by z, you need 3 equations. Whenever you have 3 variables, but instead of that 2 equations, you are just reaching to a dead end. Because right now, you don't have any idea of some kind of the third method that I can use in order to find my variables. So it is very important. At this point, we do have 3 variables. Z, obviously, I need 3 equations. And at the end of this part or this slide, I'm trying to see that is there any way that I can find a point or a specific section that is going to be absolutely right for all of them or not. So we do have 4 steps at this point. Step number 1, pick 2 equations and eliminate 1 variable. For example, eliminate x. Before that, let's see what example we're talking. I do have the system that is going to have 3 equations. X plus y plus z is equals to 6. 2x minus y plus z is equals to 3. X plus 2y minus z is equals to 2. Obviously, I have to find a way in order to solve that. Maybe some of you would say that we're going to go work with try and error. It probably is going to take you a lot of time. If you're lucky, you can find it, but still is not acceptable. So this is my initial system. Based on the first action, I have to get rid of one of those some kind of variable. How I can choose? For instance, at this point, I say I don't like to have the z at all. What can I do? I don't like to have the y at all. So it means that somehow I have to use pair of equations in order to eliminate the y itself. How I can do that? Let's see. Let's choose equation number 1 and equation number 2. At this point, I do have the left side of them. I do have right side of them. What would happen if I add the right side? It would be 9. What would happen if I add the left side? Y and Y are going to be eliminated or cancel each other. So I do have 3x plus 2z is equals to 9. If you guys remember, we were talking about that. For instance, when I do have 2 equals to 2 and I do have 4 equals to 4, I can add the left side and I can add the right side, and still those guys are going to be equal. That's why I can do it over here. So this is my first equation, which we call it as equation number 4. The equation that I just derived it based on previous 2 equations. Step 2 is saying that pick a different pair of equations. At first we used 1 and 2. At this point we are going to use a different pair of equations and eliminate the same variable. Again, eliminate the x. At this point we do have y. So I'm going to choose equation number 2 and equation number 3. Equation number 2 was 2x minus y plus z is equals to 3. That's fine. And equation number 3 is x plus 2y minus z is equals to 2. Look at this. At this point, I'm trying to get rid of y. But it's not going to be as simple as the first step. Why? Because at some point I do have negative y, and at another point I do have 2y. If I would like to add these two guys together, I still do have a problem, because 3x and no z at all. But at this point, I'm going to have y. If I'm going to keep that, I do have an equation that has x and z. I do have another equation that has x and y. I'm not going to use that. It's completely useless. So what can I do in order to get rid of y instead of letting z to be cancelled? I can multiply both sides of the second equation by 2. If you guys remember, we still can do that. For instance, when 2 equals to 2, you can multiply both sides by 2 and still your equation is right. So I'm going to multiply both sides of this equation by 2. What would happen? 2 times 2x is going to be 4x. 2 times y is going to be negative 2y. 2 times z, 2z, and 2 times 3 is going to be 6. Right now, if I add these two, 2y is going to cancel out 2y. So I do have x plus 4x is equals to 5x. 2z subtracted by z is z, and 6 plus 2 is 8. Right now, what do I have? I do have another 2 equations that I got from my first equations. But the good thing at this point is that I do have x and z only as variables. It means that if I can solve these 2 equations, find x and z, obviously they're going to be a number. I can put x and z inside one of these equations and I can find y, and that is my solution. So let's see what has happened. I do have 3x plus 2z is equals to 9. I do have 5x plus z is equals to 8. You can choose whatever way you like. You can use the substitution method. Again, you can use the elimination method. At this point, we are going to use the substitution method. What was that? The substitution method says that use one of those equations. We're talking about 2 equations, 2 unknowns. Use one of the equations. Find one variable based on another variable. Then use this specific thing and put it inside another equation. On that time, you can find one of your variables, then put it inside one of those equations, and you can find the second one. So z is equals to 8 minus 5x. It means that I use the second equation and convert it to this. So z is equals 8 minus 5x can be put over here inside the first equation. So I do have 3x plus 2 times 8 minus 5x equals to 9. 3x plus 16, because I would like to get rid of parentheses, 2 times 8, 2 times minus 5x, negative 10x is equals to 9. If you do your addition and subtraction, your final x is going to be 1. Put it inside one of the equations. For instance, this is considered as a, and I'm going to use a over here and put it inside that, and z is equals to 3. What would happen next is step number 4, by the way. Step number 3, you know, some kind of, you can simplify the 2 by system that we were talking about it. Step number 4 is the back substitute. It means that your results into an original equation, find the first variable. Right now, I do have my x and z. I can use in any of these equations, and I can find my final answer. Do that one, and you can find y as 2. It means that x, y, z, 1, 2, and 3 is going to be your final solution. Try to pause the video. Try to think about the way that I did. The 4 steps. These 4 steps are not for you to memorize it. These are there to simplify everything that you can have. Maybe some of you actually did it without knowing anything about this formula. That is fine. It would be better to know what you actually did. Pause the video, try to think about the question, and just get rid of all of the answers, write it down again, and try to solve it by yourself. Make sure you completely understand it, and by doing that, you're sure that in the future, you're going to have no problem with no equation itself, right? So then, Let's talk about a power move, solving with augmented matrices. So what was matrix? I believe some of you would know that. The matrix means that rather than just having the normal showing of the numbers, rather than just having the pair of numbers like 2 and some kind of 3 by itself, sometimes I do have different pair of numbers. Sometimes those pairs are 2 and I would like to show 3 of those 2 at a time. And sometimes I do have 3 by 3 or more or less. I'm probably going to make another video about the matrices, and they're going to be some kind of the normal and advanced, and I would explain everything to you. Right now, you just accept it by itself the way it is. If you had the knowledge about it, that would be perfect. But if you don't, just wait for me. I would probably make another video after this one and explain to you that what is happening. I try to add these examples there to make sure that you guys completely understand it. So what is the power move? The power move says that by this method, instead of just solving those kind of equation the way that I did, for instance, that I have this one, I really suggest you guys to stop the video, try to solve it based on the previous way that we had. So instead of just solving based on the last one, I'm going to use this method to try to scale a couple of variables. And by this way, I can solve the thing that I want. It means that I do have this equation, and 2x plus y plus 6 plus y plus 3z is 5, x plus 3y subtracted by z is 2, and negative x plus 2y plus 4z is equals to 7. Obviously, we know based on the previous way, we had the 4 steps and so on. But right now, I'm going to write down a matrix. And this matrix has 3 rows and 4 columns. As you can see, the first 3 rows and columns are related to the coefficients. I have to write down all of this, some kind of aligned coefficients besides one beneath each other, 2, 1, and negative 1, y, 1, 3, and 2, 3, negative 1, and 4. Write it down. Then the last column would be the answer that you have for your equations, 5, 2, and 7. After that, we have to use the 3 legal row operation. It means that by using these ways, actually I can change the column and row of my matrix without having any effect over the final answer. And these ways are swap any 2 rows, I can do that. Multiply a row by a non-zero constant, again I can do that. And add a multiple of one row to another row. At the end of the day, I should have something like this, one diagonal. And whatever I have on the top, it doesn't matter, but on the bottom, everything should be 0. Whatever value you see at the end is going to be your answer for your x, y, and z itself, which we can solve it with some kind of with the back substitution. What does that mean? It means that at this point, I do have answer for my z, which means that my z is going to be f. Then I'm going to use this one in going to find my another variable, which is going to be an equation to find another variable, and I'm going to use these two to find another one. Again, I'm saying that this one is a little bit advanced, and it's something related to matrices. I will make another video and talk about matrices and how we can use it, so don't worry about it. This is another way that you can solve 3 equations, 3 unknowns. So what would happen that if I do have this kind of power method, and I would like to see that before even handling the question, before even solving the question, see how many numbers do I have. So again, I do have my matrix the way that it was, and I'm going to talk about it. Infinite number of solutions. It means that I do have a case that my 3 variables or x, y, z are going to be true for all of those 3 equations at all the time. What does that mean? It means that if you did all of the things that I told you, move the rows, move the columns, adding or subtracting, whatever, and you reach to a fact that 0 equals to 0. It means that 0x plus 0y plus 0z is equal to 0. This is a fact. And this is going to be a dependent equation. One of your original equations was actually redundant. What does that mean? It means that you had x plus y plus z is equals to 2, and you had another equation, 2x plus 2y plus 2z equals to 4. What happened? These 2 equations actually they're the same. The only difference between those 2 is that I multiply both sides by 2. It means that this guy is completely useless. I'm sorry, I do have 2 equations, yet 3 unknowns. So at this point, I do have infinite number of solutions. Anything could happen in my case, and I can't say one answer is right or not. So the result, infinite solution, often described using a free variable. It means that one of those variables is going to cause you problem. No solutions happens at a time that you have something like this. You do have 0 equals to 5. At this point, you are going to face something that is not right. It's not fact. 0 cannot be equals to 5. So it means that this is the contradiction. Sorry about the pronunciation. And the system is inconsistent. It means that no solution actually exists. After doing all of that, if you reach to any kind of this, it's going to give you a hint what is going on. Again, don't worry about it. I will make another video and explain everything in detail. So let's talk about it. What would happen that if we deal with nonlinear function or nonlinear curves? If you guys remember, at the beginning of the point, whenever we were talking about the function and parenting function, we were talking about different kind of graphic. Y is equals to x is just a line. Y is equals to x2 is not a line, is a curve. We call it as nonlinear function. Y is equals to x3 is going to be another nonlinear function. Whatever that your power of your x is not 1, it means that that guy is nonlinear. So what would happen if I do have a system and instead of just being 2 rules as lines, I do have 2 rules. One is a line and one is a curve. So probably I'm going to face some issues and it's not going to be like the way it was. It's going to be a little bit changed. How? Just by looking at these 2 graphs. For instance, I do have some kind of nonlinear, which is going to be this curve, and one linear. Instead of just having one solution, which we knew from our system, which 2 lines are going to have one and only one point of common, I do have 2 now. So everything would be a little bit different. What would happen if I do have a circle? By the way, x plus 2 plus y2 is equals to 4 is a formula for circle. And y is equals to 2. What would happen on that time? I do have only one solution. What would happen if y was equals to 1? 2 solutions. And what would happen is, for instance, was like this, one solution. So it means that something is changing. It is not easy anymore. And what would happen if I do have this guy, eclipse, and I do have 2 lines like this, which is going to still be for the same rule. I do have 4 solutions. So at this point, no longer we are limited to lines and planes. We are now mixing. We do have line and parabolas, like this one. We do have circle and lines. We do have parabolas and hyperbolas. This guy is going to be considered as hyperbolas. This is going to advance. We're not going to talk about it. So it means that the critical change is that the number of solutions is no longer going to be 0, 1, or infinite, like the way that we have for 2 linears. It means that at this point, we do have graph have multiple times of intersection with each other. So what would happen at this point? How I can handle that? Obviously, by having some graph, by drawing them, I can have a couple of ideas what's going on, yet it's not going to be precise. That's why we still have going to 4 steps, which is very just like the way that we had for the elimination method, or sorry, for the substitution method of 2 equations, 2 unknowns. So at this point, first of all, we have to choose the simpler equation. Most of the time it's just a linear one. So sometimes it could happen. We do have a nonlinear with the degree of 2. What was degree? Degree was the power or the highest power of x. Sometimes we do have degree of 2 and degree of 3. Again, we have to choose the degree of 2, but again, that's going to be so advanced, we're not talking about it. But at a point, we do have circle and line, or one nonlinear and another one is linear. We are going to choose the simple one. Y is equals to x plus 1, and we are going to isolate it. It means that if we are going to write down y is equals to mx plus b, the way that we did. So while we are going to do that, we are going to use the substitute method. It means that we are going to plug this expression into the more complex curve, which is at this point is a curve. Y is equals mx plus b. It means that right now I'm going to choose this one to put it over here. Why I can do that, by the way, because I know if I would like to find the solution for my system, it means that whatever point that I do have in line is going to be acceptable in circle, so I still can do that. Y is equals to x plus 1 can be put inside this one. Instead of just y, I'm going to use x plus 1. So after that, what we should do, we have to solve the equation, because right now the only thing you have is just x, right? So x2 plus x plus 1 to the power 2. Guys, we know a plus b to the power 2 was a2 plus b2 plus 2ab, right? Perfect square. So I do have this one. I'm going to add them up. I'm going to do a couple of calculation over here, and at the end I'm going to reach to something like this. This is the parabola, or it's a quadratic equation. We know how we can solve it by using the delta is b2 subtracted by 4ac. If you guys don't know how to do that, I had another video over there about this one, so you can look at it to completely understand what's going on. So by solving this equation, I can find that x equals to 3 and x equals to -4 are going to be my answer. Am I done? No, because I still need to find the y's, right? So use these two and put it inside the second equation or first equation, whatever, doesn't matter. You can find y. So at the end of the day, you can understand that your line is going to have two intersection with what? With your circle itself. The x2 plus y2 is equals 25 is the formula for circle, so you can draw it just by using a table itself. So we had this for simple step for this point. So another point that we do have is about the elimination or the power move. When we are going to do that, it's going to be best when equations have matching square terms, two circles or circle and some kind of ellipse. And this one we can cancel out one at a time. So this is going to be again one of the very advanced ways that we are dealing with two nonlinears at a time. I'm not going to focus that much over this, but this is going to be a way that you can do it. Either you can use the first way, which is very straightforward, it's not that hard, could be a little bit more, it has more of calculation, but still it's worth it. So for instance, I do have this equation that root x plus 3 is equals to x minus 3. So at this point, we can solve it by squaring, and at the end, make sure whenever you're dealing with the radicals or the logarithmic function, make sure you are having a specific domain. At this point, any number being some kind of smaller than -3 is not going to be accepted. So make sure about that you end everything related to that one just before solving the equation.